Welcome, I'm Bill Wake. We're here working on a calculator to support kilt makers in making kilts, and we just finished the part where we helped them design the pleat structure, and now we're going to go back and clean up some things that we've put off for a bit. Some of it's formatting, but I think we're going to start with this notion of remembering the last tab. So as we were testing this thing, see, I should have done this, before we got going on it. We came in, we opened it, we clicked pleats, and now we do some stuff, and then we run it again and start over at the calculator and click pleat. I would like it to just remember the tab it's on. Okay. And I don't have a good... Well, the way I know to do this is there's the notion of app storage, which is usually used for things like preferences and things like this. So we would do that. And I guess we just had to make sure everything's tagged and all that. But I don't really have a test mechanism for the startup like that. Okay. Well, a tab view is this, and then it's got items in it. So here's a tab item. Here's one for the apron view we don't support yet. And then here's one for the pleat view we've just been working on. So I believe what we can do, well, I think we would create enum last, maybe it's something tab structure top. It's kind of a view things, but it's not a view. Tab, top level tab. And the three cases are calculator, apron, pleat, and pleats. Okay. Now, we can tag these. I think, does that go on the item? I know I've read a Paul Hudson article on this. Select tab programmatically Swift UI. Well. Yeah. Okay, so we have the structure. We have a tab view with views and tab items. And then, well, he's doing state, but we're going to do app storage. And then, yeah, you pass that as a binding on the tab view. But where's the tag? Oh, after tab item. Okay. So we can tag these. I don't know if I can. No, I got to do top level tab dot calculator. Okay. That doesn't affect anything, but now we're going to put a state in, or no, we're going to put app storage. Top level tab in the first, I think private bar. App storage. I don't know where that's coming from. Imp storage value. Wrapped value. Wrapped value. Well, this is exactly our common usage. App storage, my enum value. Private var value equals. Case A equals my enum.a. Wrap value. The default value of a string value is not specified for the given key. Do I say key? Maybe I should match this name? Or have I done something on the line before? No. I did match that name. Maybe private is not good. I'm spelling it right. Let's do this. Right, so changing the value writes it, and then this provides the initial default. Don't say personal data, yeah. You can choose the store. Well, he's okay with that, so maybe I have to do the yeah. Purchasing call to initialize. Well, it's the app storage it's complaining about. Where was that Apple example? Oh, it's not code. Oh, we can use strings. Yeah, okay. It maybe isn't happy with just a plain enum. Yep. Wow. Okay. I mean, I know it likes to source simple types, or you can create data and put it in there. Yeah, it's the string thing. I've got just about a 10-second delay, so keep finding your comment after I finally realize what it is. Okay, but at any rate, that's all background now. But what changes this is, I think it's selection. Yeah, selection of dollar top level tab, and we've already got content. Okay. It allows simple types. Yeah. Yeah, so string int float are easy, and then I know you can create capital D data and do it wrapped all up, but apparently simple enums are not simple enough, but that's okay. All right, so I think this should just work. Okay, so if I select pleats, and then, I don't know how is it home? Okay, let's kill this. Oh, I can kill that too. All right, and run it again. Yeah, and there we are. It's so simple. I mean, 15 minutes, before we did all this pleat stuff would have been well worth the investment. I'm sure I spent 15 minutes clicking that thing and waiting for it and all that. And let's just do a run. Well, we'll switch it to both. Okay. Oh, finished running. Okay, and now we'll change it and rerun. Oh, that didn't do it, huh? I don't know what controls the timing of it. Okay. Yeah, it's got the potential to delay a little, but it'll default if it can't figure out what to do. It'll default back to calculator, so that's okay. All right. Well, yeah, I don't have a good way to unit test this. We could set up a view test. Well, no, even there. Because we're managing it across runs. I don't know if we can even do a UI test. Can it exit the app and restart it? I kind of don't think I've ever seen that. Okay. On the other hand, it's there, and well, see, that one didn't take. I don't know if there's a pause. Sometimes these things that get written out, it does it in a background cycle kind of thing, and it may take a little bit of time. I don't know how long. Mostly it won't be too problematic, I think. Oops, do that over here. In real usage, you usually you just leave it up on your app, on your phone, right? And then once in a while, maybe you clean out all your things, and you know, that would have caught where it was going to be. But I will take it. So make it so we save which tab we're on. Right. Oh, I guess that was that. Let's... Okay, next one was decimal inches, and what this is, it's kind of getting back to this skosh thing. If somebody calculates, well, let's say you say 6/8 equals, well, it equals 6/8, okay? But if you did, let's do 6,001 divided by 8,000. Whoops. Okay, so that's kind of 6/8 plus a little bit. Okay, and it's 6/8 plus. Now, the challenge is, and this kind of goes back to the skosh thing, if it's really just like this, 6/8 plus, well, this is 1/10,000, or I don't know, not as much, but you know, this one is so small, we would just say it's fine, it's 6/8, but they can't see that. So what the request was, and I think it's reasonable anyway, is to have a decimal inches version of this, that they could switch to, and instead of yard feet inch, they'd get 0.75001 or whatever we just did, and they could see like, oh, that's a thousandth of an inch, that's not enough to worry about. But if it was 68.0297 or 0.0297 or something, it's like, well, that's really kind of close to, that really is bigger. Okay. Now I looked up, I got my wife's main Kilt instruction book and tried to find information on this, and I didn't find it. But one thing I did find was just some example where they said how many threads were in a set. And if I did the math right, there's about 70 threads an inch was what they had. And that's... well, I mean, it's clearly not a 32nd of an inch. It's close to a 64th of an inch. But when they do their pluses, they kind of think literally like a thread bigger or 2 threads bigger is kind of what they're going for. Because, you know, 4 threads, I mean, I don't know, a thin stripe on a tartan is typically 4 threads. So moving over 2 threads is really a noticeable amount of that. I mean, you can definitely see half a stripe. So yeah, that's kind of what they're up against. Okay, so we could have another selector with fractions and decimals. Yeah, although then, like, how would we even represent that? I mean, I guess we could come up with something. Yeah. I mean, it'd be like 6/8 and then plus 0.0005 inches or something. But in terms of our reader, there's no way to enter it like that. Which may or may not be an issue. I mean, that may be informational and kind of ignored. But I'm going to start with just Well, gosh, that does sound attractive, doesn't it? Yeah, so if it said 6/8 circle plus 0.00001 inch or 0.0001, that actually sounds kind of reasonable. Yeah. That's a good way to try. Okay. Let's see. At any rate, yeah, because if it were 3/16, right, that's 0.375, and now it's 0.8003 comes up. Like, how would you know that was 3/16? Yeah. So, okay, I like it. And if they hit enter, we could even make it recognize the circle plus as a plus and just accept it. That might work. Okay, so what we need is another selector. And I don't remember what that was, but we'll find it on calculator view. Okay, so selected unit, imperial formatter. Inches, okay. I'd like to change this. Well, maybe this should even be the default. I was going to put fraction in there, but yeah, that might be. I might need to change some of my widths or something, but okay, so we have imperial formatter functions. Okay, and this function takes the value and a string. Okay. Well, I think we can do that. Okay, so let's find the tests for this. Oh, what were you thinking? The interesting thing I thought about it was if I did say 6/8 plus 0.0001 or whatever, like, I'll just clear 6/8 plus 0.00001 equals 6/8 plus. So if it accepted the plus as a separator, as a true plus operator, then if it showed that and you entered it, it would all work out the same. You just don't have a way to enter a circle plus yourself, which I don't think is a problem because I think it's already confusing enough. There's two ways to divide. Okay, so how about imperial formatter test? Yes, good. Okay, so I'm going to introduce a new one. Oh, okay. Yeah, okay. And it may be that this mode of showing the whole results to maybe like 4 decimal places might be preferable. I don't know. All right, well, let's start testing. Test as fraction and decimal. The rows, sure. Okay, and I'm just going to start with some of this and kind of slowly add them in. Okay, so 0 dot input. So fraction. He does take inches. Well, what about I don't remember where our regular numbers get done. That's inches. And do we have a regular format? Well, this will give us somewhere to start. So we're just assuming this is inches, I guess, and let's make this that. Fraction formatter 0 dot input expect. Well, this also sounds like our assert thing. E.g. assert equal, where the actual is this, and the expected is $0. Let's take this one out completely. Let's fix these other two to use that. Oh. So we added this EG assert equal along the way for other EG tests, and it keeps you from having to type the file in line, which are very easy to forget. Okay, did I do that right? Yep. And this one. Well, actually, this kind of looks better like this. All right, now let's start this. So this is as fraction and decimal. Okay, which doesn't exist. It should be complaining by now. Yep. Okay. But we can put it in next to these. Okay. Well, let's fail this thing. Oh, input cannot be inferred. Oh, yeah, fair enough. And this should fail because we're not doing anything with it. Okay. We just return an empty string. Yep. Okay, now I don't. So format number gets the value, formats it. Well, we're going to have to manipulate value. Wait. Format function. Oh, inches is our value. Okay, good. All right, now this is the math thing, right? So if I want to, basically I need the leftovers from 16ths of an inch, because if it's halves, quarters, eighths, or 16ths, we deal with it. And then anything beyond that gets the minus. Boy, where's that being done? I guess it's fraction formatter. Yeah, and we have to know if it's above or below. Okay, that gets the whole number and the fraction. Okay. Yeah, we're calling rounding denominator with 16. I don't know. Split. Let's see where we use that. Okay, so if you call it right, so we pull off the whole number, and then we pull off the numerator and denominator. And what was that divided by 2 stuff? If the numerator is divisible by 2. Okay, so that gets us back to quarters and halves. Yeah, we're checking it there. Who's calling that? I mean, find adjustment is the string, right? The plus or the circle plus, circle minus. Okay, but sorry, I'm feeling very dense. I know the pieces are here. Okay, so we're taking in a number. We've split off the whole number. That's fine. Then we've gone through this to get the fraction, like 6/8 or whatever. And if it turned out it was a whole number, we add back into it. And format whole number and fraction. Well, okay, so somehow in here, right? That's the string thing. Okay, so that's not it. It's the splitting here. We've got the fraction parts of something rounded to say 16ths. I don't understand why this doesn't give me a half, but okay. So if I have the numerator and denominator and the value, right, that takes care of the rounding aspect. The rounding aspect means there's a potential difference between the fraction, the numerator slash denominator and fraction. I guess that's coming in implicitly. That's kind of weird. All right, let's pass in fraction. I think that would be a step. We don't change it in here, so it's really just I'm going to call this rounded by, or no, maybe rounding denominator is okay, but let's say fraction of type double and a rounding denominator of type int. Okay. Fraction of double, rounding denominator of int, and I get that. Okay. Well, let's find the colors. I probably mutilated that now. No? Okay. Fraction. Oh, wait a minute. Where's fraction coming from? Undo. Okay. Is that set with a side effect? No, it's set there. So why didn't it find it? Oh, I'm in two different things. Okay. Split number. Oh, this is a thing. Okay. So that really is the fraction there then. Okay. Okay, so if I say split double, okay, I'm just not sure where to do things at this point, but if I call on split double and ask it for the fraction parts, it gives me numerator denominator of the fractions, and I can also ask it for the whole number. Okay. Right, let's go to the next case. Well, presume I hard-coded the answer to 0 inches. Yeah, so it's giving us that back. All right. Well, I suppose I should just get this thing going incrementally. I think it should create a split double. Okay. And then let whole number part equal value dot whole. Okay. Now, whoops. Well, it seems like I ought to be using my fraction formatter for this and just do it. Okay, but I can build it incrementally. Let's do that. I expect both to pass. Okay. Huh. Why did it just not put the inches? What? Okay, well, I could get the first part. Okay. So I think the next one, let's do a fraction. Yeah, I think we can get that. I will need that thing, but yeah, try and. And this is 1 and our bullet 4/8 inches. I don't have any bullets in here, do I? Let's get to fraction formatter. This has got to come up somewhere. I don't know, can I get it to... No. Is that how I wrote it? Okay. Next case. Well, right now we expect this 4/8, and then I don't know where that circle plus is either. I know we saw it in here. Here it is. Skosh plus self dot. Was it number formatter? Fraction formatter. A lot of formatters kicking around here. All right. All right, that's the current expectation. Okay. Move right plus inches. I guess I left off the inches. Okay, now that's going to change. We're going to say, wait. Oh, and this is funny too, isn't it? Well, that should be 4 zeros. It's gonna come out funny. Okay. Because I suspect this is not an exact binary match. Oh, and we don't put the numbers out there. But even when we do, it's not going to work, which is okay. Right. So now we got to do our thing. All right. So imperial formatter. And this is where I want to get the split double thing back in. Okay. So we got the displayed fraction. But I think we also need to calculate this split double thing. Split equals split double of inches. All right, and now if we take split dot fraction, Is that not the right thing? Well, I think I really want this. Okay, so I'm going to get that part back. Okay. And now, yeah, we may deal with that. Well, what I want to do is let apparent result equal numerator. Okay, so now I've got the fraction. And I think what I got to do is take inches, well, split dot whole number plus apparent result. That's inches minus that. So if I take the whole number and then the fraction, okay, I'm not worrying about negatives yet. Yeah, I don't know. Okay. That should give me the skosh amount. All right. And then I want to okay. Well, I need a plain old formatter. Somewhere we have one. Number formatter. Okay. Number formatter dot string for string from Oh, I've got the inches in the fraction part, don't I? Oh, annoying. All right, well, let's get it as wrong as we can. Gap string. I don't know if I like the 1.4 8.001 because I mean their standard is just plus or minus. I don't know. This is a little experimental. Oops. All right, and this is, I'll just hard code it for a moment here. Well, let's at least put max denominator. Static function. Okay. Wow. I think it's going to say 1.48 inches, 1.48 plus inches, 0.001 or whatever. 0. Oh, well, 0 is wrong. How's, I guess this, let's take this off here and put it here. And format number, string, puts the label in the back. All right. Well, 0.001. Did it round it? Maybe I'm working at the wrong level. This all feels like numeric-y kind of stuff, at least to there. That split fraction parts could kind of tell me, I think. All right, let's break here. We're just going to run this one test. Yeah, but I don't know if it is. Yeah, maybe that may. Well, maybe that's getting to another. If they trusted the skosh, well, that's the thing. I laid these out. Maybe let's back up a little. So we've got, let's say this is an eighth, which is 2/16. And then somewhere over here, we have 3/16. Okay. And then 3/16. Okay. And I need a line. Okay, so I think your suggestion is here's 2/16 plus 1/64, 2/16 plus 1/32, 2/16 plus 3/64. I guess I could be consistent. 2/64. Okay. So I think what you're saying is this zone is pseudo pluses, and then the next half is pseudo minuses out to here. And then those less than a 64th gets rounded to the whole. Yeah, I mean, that's the thing. I think maybe this. I think the request for this decimal inches thing is at least partly coming from the fact the skosh today is right now it's like this. Right. So 2/16 exactly comes up as 1/8, and 3/16 comes up as 3/16. But anything the tiniest bit away from there does not. Now, I think and so since they don't know whether they're on this end of things or out here practically to the middle, they don't know whether to trust that answer. And I think this might be an adequate answer. I mean, so the error, like, you got to think what the error is, right? So if it should be, let's say 2/16 plus a 32nd plus 2/64, versus 2/16, right? Then your maximum error is 2/64, 1/32, and 30 pleats is not unreasonable, so it's an inch difference. Okay. Now, if we did this way, the maximum difference would be half an inch, right? Because we're sort of lying about this being the same as 2/16. And so if you multiply practically 2/16 times 32, you get half an inch. And same for this zone. If it should be a 32nd, but you treat it like a 16th, And then how does that go on the other side, right? You're off by a 64th on either side. Yeah, that really is the question. If my math was right, at least the example they gave was about 70 threads to the inch. So a 64th of an inch is kind of the right, is pretty darn close to being a thread. Which to me, this is like, well, it's their domain. They get to decide. But if something is, well, let's see, the middle is 1/32nd. And so if it's 5/32 versus, to be in the middle between the 16ths and the 30 and the 2/16 and the 3/16. I don't know, nobody has a ruler that measures a 32nd of an inch. I mean, none of these sewing rulers do. There may be some out there. I don't know. So really, maybe, I don't know. Oh, let's see. We're still running. Where are we? Okay. So right now the gap is that. So if I, where's my console? If I print, NS number value : gap. Yeah. If I print number formatter dot string from that, is that coming up as 0? Well, that simplifies this a little, but okay. Well, let's continue out of here. All right. Well, what it simplifies is I don't have to worry about gap 0. If that helps. But I mean, that's 5 digits. Let's change our test to 4. See if that's enough, because an 1/8 of an inch is 125. A 16th is 0.0625. A 32nd is 0.0325. And then a 64th is 0.0121125 or something. 0.125, 0.06. So we won't have that much a gap. All right. I'm still expecting a round off error. Okay. How is it still 0? Why is there no space? More to the point. I guess I lost the space doing it manually. If gap string is 0, Why did that come up? I don't see how that would come up with a 0. .015625. Okay, good. Yeah, so if you get to 128s, right, then you're down to the third decimal digit is the significant one. All right, I don't know. If they trusted plus to mean something approximately right, then I don't think it would be an issue. Like, they wouldn't care about this decimal display. And, and really the decimal display, like, these people are not, arithmeticians or mathematicians. They're not going to know, negative powers of 2 off the top of their head. I mean, I'm pretty good on the positive powers of 2, but I'm not going to, I'm already lost when I get down to a 64th. If picture B here, if this is A and this is B, was good enough, and what it says is over the space of 32 pleats, you'll be off at most ½ an inch. And this one says you'll be off at most an inch in 32 pleats. So I think the quilt my wife's working on right now is 29 pleats. And I know she's seen some that are, in the low 30s. I don't think she had anything bigger than 32 maybe. But we know the number gets multiplied that big. Now, what I was going to say was it could be... I guess I was going to say we could make an adjusted size, but like you could multiply this back out at the maximum error rate of a 32nd. And if you had, here let's take 1/6 and 20 inches at 2 inches. Okay. If I took this value times the pleats, like right now we're displaying the value is far down to the decimals, as we know, rounded off, but the value itself is still, being used up to this. Another approach would be take this value, if it came up, well, let's try and manipulate this into what we want. Okay, 1 7/8 plus. We've got an 1/8 inch plus overlap. Right. Now, one thing we could do, well, one way would be we could just assign a 64th of an inch. Well, is that even right? Maybe we are into the 1/28th. We could pick the middle value here. That one is 2/16 plus a 64 plus a 1/28th, and assign that as sort of the representative of 2/16 plus. Okay. Or we could put out the range on the hip. We could take this fraction, and if it's a plus, if it comes out even, it's fine. But if it's a plus, we could say the adjusted hip size is 19 to 19 3/8 inches. Okay. The multiplied value. Okay. Because adjusted hip size, remember, is number of pleats times the width. So if we multiplied 1 7/8 times 19, times 10, 0.875, right? So it'd be 18.75 inches. That would be without the plus. But the next biggest number we would represent is 15/16. And I can't do that one in my head, but if you said the range was 18.5 to it's probably 19.5, okay, that would tell them like you know your range could be that. Now if we adjusted this so the 1/28 was our guess, we could just make a guess and say if it's any plus, call it 1/28, 64th plus a 28th. If it's any minus, subtract a 64th and a 1/28th, or however that would work out. That would give us small enough range. Yeah, it's kind of plus or minus something. I mean, plus or minus would be another way to say it too. We could say it's 19 inches plus or minus half an inch, the way we are now. Plus or minus an inch, the way we are now, because we'll allow ourselves to be a 16th off, right? Or at least a 32nd off. I guess it's a 32nd off. So, yeah, so maybe it's plus or minus an inch in our scheme and plus or minus half an inch in this one. I don't know the right answer. So, well, we're due for a break. So tell you what, let's take a break. I'll see if I can snag my wife for a quick answer on this. I don't think she really knows, honestly. They don't think about it this way to say like, well, plus must have a range, and what's that range, and how do you should it be a 1/28? Like that's not gonna do it. So we'll see. All right, so 3 or 4 minutes, and then we'll come back and do something. All right, welcome back. Okay, so I have well, basically we're going to do this approach of saying if it's off by a 64th, if it's less than a 64th, just treat it as if it were the same. If it's more than 64th, then divide up the pluses and minuses. She talked about, I mean, she definitely was thinking about having the decimals, but the problem is, like when you get 0.0324, you don't know, like unless you've got your fractions memorized, binary fractions memorized, you won't know how much that is or if it's close or not. So I think we will back out of doing the formatter approach and go back to our basic math that decided what a skosh was and do it that way. Okay, so let's take out some tests and junk some incipient code. Okay, and the formatter. Okay, make sure tests pass. I'll leave these constant assignments in there. I think they help a little bit. Oh, except nobody uses this one. Right. Okay. Yeah. What it sounded like was the being off half an inch across the 30 pleats. That's kind of in the range. Like people get off that much as it is. So what they do is like every three or four pleats, they check their measurement to say, I was supposed to be creating, some distance of my pleat, based on this, how close is it? And if it's big, they adjust in the next set of pleats and definitely halfway across they check to make sure it's halfway done. So you know, I don't that like they don't talk about 30 seconds of an inch. You know, once it's this this plus or minus thing, they treat that as like they call it a thread. You know, being a thread off. I expect it's closer to 2 threads based on what I saw, but you know, it's kind of the way they say it, just to say like, you know, you're down to the limit of what you're doing. And actually different kilts, different tartans get made in different thicknesses of material. Like the real military weight stuff is a very thick thread, and then the normal kilt is a lighter one. And then when you get to the dancer tartans that are, you know, they call it 11 ounce or 13 ounce, I think that's per yard, they're even thinner thread. And there is pseudo tartan that's made with really thin thread. You know, so even there, you know, it's there's some variation. You know, if you're talking about a light tartan, it might be 2 threads or 3 threads. But anyway, all right. Let's check this in. Some cleanup, but mostly we put in and took out code. Okay. Now, I kind of feel better working at the value level. Like this stuff. Where'd that go? Okay, I made this public. I don't think I need to do that. Okay, so somewhere in here. Well, let's find skosh. Okay. Yeah, so I think what we're going to say is if the difference, if the computer is less than the number and the difference is less than a 64th, is that going to do it? The absolute, well, I guess we could subtract it if we know which one's bigger. If the distance is less than a 64th of an inch, go back to my to-do here. So we get some value here if we subtract the 2/16, and what remains is less. I guess this is the 64th. If it's less than that, then call it nothing. Okay. So value formatter. All right. So where will we? Let's hope we have some value formatter tests. Yes. Good. Okay. Well, this is going to be skosh distance size. All right, and then EG. We'll have a message in ours. So value dot number. Is this formatting? Well, again, these can be EGs. We'll take this one out. Okay. Okay, so if we take, let's see, and I expect, okay, number of 0.75, we expect 6/8. Really? Oh, okay. All right, this should pass. Okay. Well, I don't think I mind seeing them like that directly. All right, now this one should pass too. Ooh. Oh, well, that's... Six eighths plus. All right, let me do a 64th. Am I? Two 64th plus a 64th. It shouldn't be 3/16, right? Fifteen sixteenths. How is that right? Six eighths is 12/16. So how do we get up to 15/16? Did I read it right? Is there a zero in there? Yes, there is. Thank you. Okay, 1/5/65. Okay. Yeah, it's just too big. Okay. All right. So a 64th, I guess if it's if it's a 32nd, well, we got to decide, I guess. I don't, but I think that might be this 13/8 minus. Yeah, 13/16. Which actually is kind of what I want. Okay. And then now this one, if it's plus 3/64, I'm not quite sure where that one goes. I'm going to make it minus a jot. And I still expect a minus on it. Okay. Okay. So notice these are all true about our existing code. Now we got the ones that are that we want to be altered. So a 64th minus a jot. Diff is too small for a skosh. Add the jot on line 60, which is now 61. Well, I think there's a case. That will come. I think, yeah, let's just put all these cases in. So if it's a 64th minus a jot, we think we're just going to call that 6/8. Okay, so these two are, well, wait, that's a duplicate. Okay, these are the pluses. 74th plus a 64th. Okay, so I'm going to do 74 plus 2 64ths minus a jot. Okay, so we're just to the left of the center line. I want 6/8 plus still. Maybe barely. In range. Okay, and then 2 64ths should be, I mean, I would like that line, the 32nd, to be given to the other side. Because a little bigger is better than a little smaller, if you're talking about, you know, 1/10 of an inch. 2 64ths plus a jot. Well, that's certainly big enough. But 264 minus a jot. Now we need the case plus a jot. Okay. So now we're just outside this range. We're on this space. So we just got too big for a negative skosh. Okay. I guess I want to make sure I covered the cases. So we've got an exact one. We've got one just in range of, we're going to treat it exactly. Then we got the border where it is 64ths. And then on the far side, it's just barely in range. This one is just big enough. And this one's just small enough for skosh minus, and then just a little bit bigger than that is 13/16. Maybe I should say not exact, but too big for a skosh. Okay, for a skosh plus. All right, and now I expect some tests to fail. I mean, it's funny, I learned about boundary testing a long, long time ago. I mean, it's been around since at least the 60s and named. Okay, and this is actually good for us because this is the one that's just too big. Just, you know, just too small for a skosh plus, just too big for a skosh minus. Those are the cases we don't cover now. All right. And that's the one we got to do the work on. All right. We do it one time. Good. All right. Let's go look where those skoshes get put in. Yeah, and I like your idea if if the absolute value of, check the decimals for the jot. Am I? Oh, man. And I hated them lined up. Is that going to be right? I guess this would be a stronger test, right? Okay. If the absolute of computed minus a number is less than skosh cutoff, return nothing. Okay, now I don't know if this is going to pass both those because I'm a little worried about that 64th in the middle or the 32nd in the middle. But we'll see. Oh, something else failed. Oh, well, that's good. That means our test passed. Oh, and a rounding test. Okay. That is correct. Round eighths to whole numbers. I think that is correct. We'd have to be... Well, okay, we do have a 2 minus. Why did that one pass? I'm not sure we're quite there. I'm looking at line 365 very skeptically. Why is that not 2? It's 0.01 off. I guess that's why. It's still big enough off. But then why is this one... like they should be symmetric, right? If one's off, the other should be off. And what's the other one? Slightly big. Well, this is actually slightly big, and this is slightly small. Well, 0.01, right, is... Okay, we got our fraction. 0.015 is our fraction. Another decimal. Well, no, that... Excuse me. Let's go back to the test. So I'm... Excuse me. I mean, if something is different by less than 0.01, because if it's different by less than 0.015625, including 0.01, it should have rounded a number to the correct thing. Now my jot, I don't think it's going to matter because I'm just making it 1/6. Well, no, does it? It's still smaller. I mean, I can put a bunch in. Maybe not as many as that, but I can put a bunch in. Yeah, it's not a question of that. If my jot was 0.01, then maybe I might have a complaint. But, you know, since I know it's exactly this and I'm forcing it to be lower and we're still in the range of, significant numbers for a binary decimal or a fraction in binary, it's not an issue. 156249. Yeah, I mean, I'm definitely. Well, like, is that going to be enough? I guess that's what you're saying would be a good, comfortable thing to know. Okay. Doesn't look my spacing. Yeah. So, I don't know. Is there another name I can use for this? I can't start with it. I don't think I'm allowed to start with underscores. Or jot. Jot. let's. Well, that doesn't look right either. Jot. Let me rename it. I don't know. I just think the formatting will help. I don't like the naming, but I don't have a better name. Every jot and tittle is the expression. Yeah. 1/64th. Jot. No. No. I think I'll leave it like that. Whoops. Okay, but I'm puzzled here, right? So I would have thought, 1.99, 2 minus, yes. Oh, negatives. Yeah, that's an interesting problem. Are they big enough to matter? 201. What did this come to? -2? It's something. We did do some stuff to take care of negatives. Mostly we split them off. Split off the sign. That's... Is it too small? You're saying this one really is... Oh, yeah. Yeah. Its absolute distance is 1/100th. So that's less than 0.016525. 0.015625. So it should, but I'd like one that was just big enough to be a problem. I mean, I'm okay with that one. Like 202, however, should be a minus. Okay, let's see how these do. Because I need somebody who can be trusted to do this with a negative. 199. Well, wait, this is slightly too big. I've covered minus, minus plus, minus plane. I need a minus minus. Oh, okay, he passed. Good. All right, now this one. What did he get? 15/16. I don't know, where's the calculator? Yeah, I'm 199 over 100. Let's run that. So 199. It's 0.01 difference. I mean, I would expect 198 to definitely be big enough. Eighth of 100. I would expect that to be a 2 minus for sure, because again, big 2% instead of 0.015% or 1.5. All right, let's run. I guess I don't have to care about those. Okay, so now I want to stop in the formatter. Go here. Okay, A number is 1.98. 2.0 minus 1.98. Can I do this? 0.02. Am I working on the right one? Let me continue. Okay, 1.99. That's what we want. All right. Computed is 3. What does that mean? 1, 2. Well, I think we lie somewhere here. There's something funny. Somewhere we add 1. Yeah, right here. Because if it's 99 out of 100, you're going to say, that's practically 1. So that's whole number. Okay, he's 3 at this point. Yeah, who calls fine adjustment? That's down here. Yeah. Okay. So this all comes down to a number. That's the original. And a split number. So fraction marks calculate the decimal value for the fraction. Okay, so are you talking here? I'm wondering where this case even comes up. Well, I guess they've rounded. Yeah, so this is the rounded numerator and denominator. And well, depending on the value, right, 99 should round up. So the whole number gets increased. But I think at that point, find adjustment is comparing to a number, not to split number. I think these should have gone. Okay, let's see if we can make this work. Numerator equals 0. Yeah, I don't know if this will break things. I think this test is the focus of that situation. Okay, let's continue. I just want to see where we are in the whole test. Okay. 199 rounded to 2, which it should, right? Because it's only off by 0.01, not 0.015. Okay, so I think the test is wrong here. Okay, 1 minus 199, I guess by the same reasoning, that should be a 2 as well, yes. Okay. Now, 201, we expect the same. 202, 2 minus, 2 minus. 2 minus. Okay. And 2. 1 off is too small, 2 off is big enough to trigger it. 99 of 100, I would think that should be wrong. Yeah, according to us, 99 of 100 should be minus 1. But 98 of 100 minus 1. Well, is that a minus or a plus? I guess it's a plus, right? (148/16). That I don't know. 199, it should be 2, yeah. I mean, I'm glad these are changing because they should. Okay, let's see where we are now. I think there's still one that's maybe 2 that are off. Decimal equals numerator denominator. Well, but it could be, it's rounded, so it could be off at this point. I think that's the point of this stuff. Computed. Oh, where's computed? Okay. Decimal fraction. Yeah, are you talking here? Okay, I'm gonna, it should be because a number is not rounded. Yeah, a number is the original. Computed is, I think as double already is what you're saying. As double. Yeah, so it takes the fraction is that. Okay, I'm going to go back here. What's still wrong? All right, 15/16 minus. Oh, got to divide 2 by 160. Okay, not 2 by 100. 2 by 160 is too small. Okay. 3 might be big enough. I don't know if I've got this whole number one right. Okay. Yeah, let's get this, make sure this whole number case. Okay, so yeah, this one in particular. So 199 divided by 100. The 99. Let's see where it computes it. Okay, the 99 over 100 rounded to 16ths is going to be 16/16 when we come back from that. So we're adjusting the whole number to reflect that. And now we've cleared the numerators, so they don't show up. Let's make sure that's true. Has fraction numerator not equals 0. Okay. Oh, I guess I sort of guarded it there. Yeah, I guess I pushed the guard around a little bit with that move. Fraction, that's the absolute fraction in decimal. Okay, I know I'm doing something too hard. Okay. So we have the number, we get the split. And then I think okay, so if they do something that's like the equivalent of 1.99999, they'll get a fraction. It'll round to 16/16 when we do the rounding in this split number thing. And so the whole number we need to format goes up by 1, and the numerator goes to 0. And then we format that whole number and the fraction. Okay, with the numerator equals 0, it doesn't do any fraction stuff. Then we do an adjustment if the number versus the number we have calculated is that right? So yeah, okay. Absolute version decimal. I don't think the fraction in decimal. Well, it's the as double thing. For a certain action, is that absolute numerator denominator? Are we talking up here? The as double is absolute. Well, no. Split as double takes the sign back into account, so it's the signed version of that. But the split is not the fraction parts are not maintained by that. They're only given to you here when you ask for it. Now, whether that's quite the right thing, but we do take absolute value because the sign is pulled out. We take the whole number, and then we could make this a rounding thing that did this work when it initialized it. Maybe, I don't know, maybe this would be, it's the formatter that's doing that, but I don't know, this feels about right to me. We've taken, the split that's coming in here is the one formed from our earlier stuff. So it's adjusted by this fraction. Let's see, where's this? Okay, so here we have the whole number from the thing and the numerator denominator. And we format those and then slap the sign on, basically. Sorry, line 19. Yes, this is, you give me, I mean, normal use, this is going to be positive no matter what. But yeah, you're getting the absolute value of those. And so I'm not sure. Let's see. I mean, this thing all started off as wrapping that. And then we wanted some pieces out of this thing. But I don't know if we ever asked for the fraction. Let me search for this one. Right, that's all only in here. Yeah, this is not really looked at as a fraction anymore. I mean, could be. It might not be wrong to, I mean, maybe we should be reconceptualizing this manipulation. I mean, this part has fraction. I mean, it's a mix of the string side and the numeric side, and we're doing a little bit of numeric stuff here. I think, okay, let me pause momentarily, make sure tests are running and check this in before I get too far off field. We seem to be working pretty hard to get what we're getting. I agree. It's not, doesn't feel like it's as simple as it should be. All right, but what we did was we enforce that a plus skosh is x is 1/64 to 1/32, and a minus skosh is 1/32 to 3/64. Yeah, let's find computed. Sorry, I'm not seeing it. Okay, split as double. So, the split is the result of the fraction computation, the rounding to the 16th. I mean, if I called this rounded, it might work a little. Split double. What do we do with rounded? Nothing. Original and rounded, and let's maybe pass in as double. Find adjustment, split double as double. Okay, and I want to see if this reads better now. Okay. Okay. I don't know, does this... I think the names help. I don't know if subtract, which one should subtract first. But yeah, computed was the, whatever fraction we decided it was, like 6/8, it's that, like 0.75 for that. And it's rounded to 16ths, so that it's always a multiple of 16, or if you multiply it by 16 and take the fraction remaining, you don't have anything left. It's cut off. So this is given the original and given the rounded value, which could be the same as the original if it was exact beforehand. Then first we check if there's not enough difference. Then we check if you're less, then you get a plus. If you're bigger, you get a minus. Otherwise, otherwise it's kind of like can't happen at this point, but you get nothing. I think it's making the right decision. I mean, convert, given an original and rounded value, tell me what the skosh is. That feels right to me, that we have to know that information to compute it. Because that's kind of what it's all about, is like, is the fraction good enough? So I think it's okay. Now, I'm not sure the reason for going back to split double here. And this is basically reconstructing the number after the rounding. And maybe that's the whole deal. Like, maybe that's the thing we want, is this number. Like, this should all be part of that computation. Let's see. So this is fraction format or dot format. I'm going to catch a note here before we go too far. Okay. Fraction formatter dot format, let its computation move into move that into the split double dot fraction parts. Fraction parts. Okay. So, because I think you're right, there's something's unbalanced there. Like, this stuff is numeric computation, and all this stuff is being, well, the signum is okay, but this stuff is being gathered. I don't know. It'll be worth thinking about next time. So let's see. Next week I'm still here. The week after, I think I'm on vacation. But we'll pick up here next week, starting Monday, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC, and we'll continue on this skosh adjustment stuff. And I still do want to get the EGTest stuff integrated in too. You think you only need the check before the plus or minus bit? Okay, let's add that note in as well. Okay. All right. Yeah. Thanks for pushing me on this. It definitely should be simplified from where we are. I think if we can find the right kind of numeric abstraction, we'll be okay. All right. Anyway, thanks again. I'll see you Monday. Have a good weekend. Bye-bye.